G over the Galois field, which one? GF2. Okay, it is the notation. Galois field, and also we can write here modulo 2. Modulo 2 means it addition modulo and multiplication, GF2. If WG, what is it? Is WG. If WG satisfied all the axioms of vector space under the following composition, under the following composition. Following composition or rule. Following compositions. So what is the composition here? because we are saying about this one, this WG is nothing. What is WG? WG set, and this set is a subset of all subgraph of G. Are you getting? Okay, so what are the operations here? So operation is that first one is called the addition operation, addition composition. First one is addition composition, and it say that suppose the X, okay, composition say that this is the addition composition, and we can write from it is WG cross WG to WG, and we can write here what we write, suppose here WG nothing, G1 G2 belongs to WG. First, it is clear? It is clear?
Yes, sir.
And second composition is called scalar multiplication. Yeah, scalar composition, and it say that, so basically we will denote this composition by, it is a plus, and also we can write multiplication here. Okay, so I can write here this one, okay, for like this one, for from here GF2 cross WG to WG. It is clear? Here, this one is the field. It is a non-empty set WG, set of all subgraph of G. It's means go, and it is defined that C is this one into G, which is belongs to WG. It is clear? It is clear? It is clear? Any doubt? Okay. Okay, scalar composition. And satisfied the following properties also. Satisfied all the exam of vector space. And what are the exams? First one is WG is commutative group with respect to, I will not write in detail, you know about these very well. And second one is scalar, is it a commutative group with respect to this one? And also we have some following properties, that properties followed by the scalar multiplication, that is equal to. So what is these properties here? Just you can convert it, this one. I have write all these. Okay. So here it is mentioned that this is the field in which we have used operation addition modulo 2 and multiplication modulo 2, and this is represent the scalar multiplication. It is clear? And here this is the vector addition. Okay. So you can write all these property which I have mentioned here according to the operations vector addition, according to these. Okay. In terms of this one, this composition and this composition. Okay, it is your work. Okay, that will be the definition of a vector space associated to a graph G. Clear? Now, this is the definition. Okay, now how to find? In this definition you have seen that WG is nothing, it is a all subgraph of G with to the power E vectors, means this set contains to the power E vectors, means E tuples. So how can we write a subgraph in terms of a tuples? Question is that. Okay, for this consider okay, basically it is the only definition of a graph. Okay, so for this let's consider a graph G. Suppose I take the graph this one. Okay, it is E1, it is E2, and it is E3. Okay, these are three vertices here, V1, V2, and V3. There are three A's, E1, E2, E3. Clear? So I can say that. So how to find first of all WG? WG is a all subgraph of G. It is G. So what is the possible all subgraph? What is the possible all subgraph? First one is how to find the subgraph of G. Are you here or not? All the students, are you listening to me or not? Okay. Not responsive. It means you know everything. I move. Okay. So here it is a empty graph. I can write this one, and E1 this set, E2 this set, E3 this set, E1 E2. Okay, or like this way, and I will graph E1, E2, E3. So it means that this graph contains to the power three elements, and you can 1, 2, 3, 4, and continue. You can find there are 8 vectors. Okay, so basically this is a first graph. This is a we can write it is sub z naught, it is g1, it is g2, it is g3, and up to this is how many? These are 8. Okay, it is g naught, g1, g2, g3, and also we can write it is capital G here. Okay, now, so here P1 is nothing, it is phi, and phi can be written as. Now, question is that how to write this graph. So you can see that number of A's are in this graph. 3, E1, E2, E3 is given. And also I have told you that with E to the power E vectors means E tuples. E means number of A's. Number of A's are 3. So I can write this graph phi in terms of 3 tuples. Which one? X1, X2, X3. Okay, and all are 0. So how to find this? This is a subgraph. And what is the G1? G1 is also a subgraph. Okay, we can write this graph in the form of like here only E1, only E1, only E1. Okay, so first of all, I would like to express this graph in terms of 0, 0. Okay, and I will write this graph in the form of 1, 0, 0. How can we write this one? So it means that because it is a graph with 3 A's. How many A's? There are 3 A's. Okay, so we can write the value of these xi. Okay, so I'm writing here. Okay, so ordered will be in the form of x1, x2, x3, such that so xi will be 1 when if as ei is in G1. Okay, and xi will be 0 if ei is not in G1. Okay, so in this case you can see that x1, x2, x3. So basically it is a null graph and no A's lie in this graph. So I will write here 0, 0, 0. And in this case you can see that here G1 has only one A's, E1. One is E1. So in triad, in triplet x1, x2, x3, in this A is only given here. This A is given here, E1 is given here. So just I will write here 1. I have write here 1, and there is no others A's in this graph G1. So I will write here 0, 0. Okay. For G2 graph, how many A's in this graph? Only G2 is this one, and this can be represented as the ordered pair, means in tuplet, means 0, 1, 0. G3 also can be written as E3, and it is nothing 0, 0, 1. Okay, so we can write G1 in this form or like in this form. Okay, G3 is in this form or like in this form. Same here. If I take this one, G3, it is G4. G4 is E1, E2. G4 is E1 and E2. So we can write E1 is here, so I will write 1 in the graph. E2 is here, I will write 1, and in the third edge is not lie in G4, so I will write 0. Okay. If G basically contains all the A's, E1 and E3. So what is the value of this one? This one is 1, 1, 1. Okay. So this graph, this is the graph of all subgraph. This is WG is a set of all subgraph of G. So this graph, this is written in the subgraph of G, and also this graph is can be written as in the form of like this way. WG is can be written as 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1, and 1, 0, 1, and finally 1, 1, 1. And you can see 1, 2, 3, 4, 5, 6, 7, 8. Total number of element in WG is 8. 8 is nothing to the power 3. So basically this is a non-empty set W. Okay, and this WG is a vector space over the field GF2. Okay, it is clear? Okay, now you know about the basis. I will not discuss this one because you know about or what is the basis. Basis means it is a set of vectors which is linearly independent, and that set generate the space. That is the basis. And also you know about the subspaces. Okay, subspaces means a non-empty set is called a subspace of any vector space V if V has a vector space under the same operations. And you know about this one. Also you know what the dimension. Dimension is the number of element in the basis. Okay, and suppose G is a graph. Okay, then we have basically G is a graph and WG is a vector space associated with this graph G. Then it has, we can define two subspaces. First one is called the circuit vector subspace, and second one is called the cut set vector space. Okay, so first one is the circuit subspace. It is denoted by like this one, and second is the cut set subspace, and it is denoted by gamma, I suppose S. Okay, so these are two subspaces. These are two, W gamma and WS are two subspaces of a vector space WG, which is associated the graph G. Okay, and also means we have two subspaces, this one and this one, means circuit subspace and cut set subspace. Okay, then you can find You can find the what is the dimension of these subspecies. What is the dimension of these subspecies? And also you can find what is the orthogonal subspecies, ortho orthogonal and orthonormal subspecies. Okay, you can calculate. You know what about this condition means? How can you calculate two vectors are orthogonal and not orthogonal? Also, you can find what is the intersection and join of two subspecies. Okay, basically these are the operations between two subspecies, and you know about these operations very well because you already study the vector space in previous class. Okay, just you will take a graph, and from this graph you can write a vector space associated with this graph. Okay, if you can write a vector space associated that graph, then you can write all the theory of linear algebra. You can implement all the theory of linear algebra in terms of a graph. Now, if you have any problem, you can ask. Otherwise, I stop here. Any query? No, sir. Okay.
सर स्लाइड शेयर कर दीजिए.
Okay, I am sharing slide. Okay, first I am making your attendance, then I will DST.